arithmetic progression, the only thing you need to check is if you jump from one number to the next, is the jump size remaining the same? That's it. That's the only condition you need to care about. And let's see over here. Here the jump size is +1, +1, +1, again +1 over here, and +1 again over here. And I'm going to trust that this person who put the ... will continue to follow this rule, and therefore I'll say, oh yeah, this is an arithmetic progression because the jump size is a constant. Here the numbers are just natural numbers, 1, 2, 3, 4, 5. So the set of natural numbers are an arithmetic progression. Now let's look at a few more. If I ask you, let's say 1, 3, 5, just 3 numbers, are they an arithmetic progression? What will you do? The only thing that defines an arithmetic progression is the jump size constant. So you will jump and you'll notice that, okay, that's a +2 jump here. There's another +2 jump here. So the jump size does not need to be 1. It can be 2. But it's still, and it can only be 3 numbers. It doesn't have to be a long sequence. Then these 3 numbers are an arithmetic progression. Okay. What if I have something like this? Is this an arithmetic progression? I know only one thing to check this. +3, jump size 3 again, jump size 3 again. I'm going to say this is an AP. So maybe we should put like that's an AP, this is an AP, this is an AP. AP is a short form we use to say that these numbers are an arithmetic progression. Let's do this. 1, 4, 9, 16. Is this an AP? Let's see. There is a +3 over here. There's a +5 over here. I don't have to check any further. This is not an AP. No matter what happens over here, this cannot be 1 because the jump size is different. So the jump size need not be 1 or 2. It just has to be a constant. But the moment it changes across, then we know this is not an AP. Let's see what more we can have. Let's say that we have 3, 5, 8, 11. Is this an AP? Over here, that jump size is 2, +2. Over here, it's +3. That's it. I'm done. I don't need to check any further. I know that this is not an AP. So not an AP. What if I had 8, 5, 2, -1, -4? So first, you notice that this is reducing, right? So 8 to 5 to 2, that doesn't matter. My jump can be a negative jump. Even though I'm drawing it like this, in my mind, I'm actually going left in the number line, right? So I jump a -3 to get here. I jump another -3 to get here. Another 2 and then -1. So -3 to get here. And another -3 to get here. So this is a arithmetic progression because the jump size is remaining a constant. So you now know that the jump size need not be a positive number. It can be a negative number for all we know. Let's look at one more. 7, 7, 7, 7. Is this even a sequence? It's just the same number repeating. Is this an arithmetic progression? I mean, I'm just going to do the same thing. I'm not going to think. I have to jump a +0 or a -0. So +0 and a +0. In other words, I'm standing on the same spot on the number line and just standing over there and jumping in the same spot. Stationary jumping. But is this changing? It's not. So like we said, the only thing we check is the jump size changing? Is the jump size changing? It's not. Then you say this is an arithmetic progression. So in summary, if you just look very quickly, you can see that the number can start wherever it wants to. Right? It can be 1, it can be 4, it even can be a negative number where you start. It doesn't have to be a positive number. So if I make up some sequence like this, -3 to 0 to 3 to how much will that be? 6 to 9 and so on. This is an arithmetic sequence because you have your +3 to get here, +3 again, and so on. So you can start wherever you want to, positive, negative, 0. This could have been, the arithmetic sequence could have started right here. These numbers will also be in arithmetic progression. Arithmetic sequence is just another word for numbers that are in arithmetic progression. So a sequence is just a set of numbers, right? So this is what you have. Notice that also the common difference can be positive. Now that's a bad example to show. Let's say somewhere over here. Yeah, it can be positive. It can be 0. And it can be negative. So the only thing you need to know to solve any problem in arithmetic progressions is this: that a set of numbers which have the same jump size between them, can start wherever they want to, can end wherever they want to, are called or said to be in arithmetic progression